to EF. So when I look at G right there, G, that's not the opposite side, is it? So as I stand at G, that is the opposite, and that is the adjacent, isn't it? So when I look at that ratio she's pointing out there, um, those are all kind of reversed, aren't they? Reciprocal. So that should not be G, should it? That should be angle F. So opposite and adjacent, based off the two ratios they have, opposite and adjacent, that's what they're going for tangent, which is fine. This should be angle F and angle F, I believe. So tangent ratio, the inverse tangent, that's the first thing I'm looking for off that, realizing at least, hey, if I'm going to use tan to -1, we call that our inverse tangent, or we also call it the arc tangent again. Arc tangent, inverse tangent mean the same thing. All right, but EG over EF, that's not the right ratio there. That's not the right angle. That's my reference angle of angle F. Okay, so small thing to point out. If you didn't catch that, no big deal. But that is what should have been. Okay, thank you, Eva. I need to make sure I update that next year. Keep going. Any other questions? Seven. Sure. Let me bring up the calculus. Again, you guys are my first line of defense. Always make sure you guys catch something. Let me know. I appreciate that. All right, 7. You said okay. Yeah. All right, let's go find 7. Is that on the next page? Yeah. All right. 777. Oh, that's the calculator one. So with that cotangent ratio, we're going to evaluate that, and on that one, we said our calculators can't do that. But what our calculators can do is sine, cosine, tangent. So we have to realize if we were going to go calculate the cotangent ratio of 42, we're going to ask our calculator instead to do the reciprocal. Okay, reciprocal of tangent. So 1 over the tangent of 42 is what we're going to ask our calculator to do. So what your calculator is going to then do then here is go look at the its trig table. Now cotangent is what? It's adjacent over opposite, isn't it? So it's going to go look at the 42-degree angle, and it's going to go look at the adjacent over opposite then, find that particular ratio that has the adjacent and opposite ratio of that. And it finds that it's going to return that ratio. And what we can then do then is take that decimal and we can write it as a fraction. Okay. Now we're not going to worry about doing that. But when we rewrite that as a fraction, that would be then written as the adjacent to the opposite side. So in this instance then, to get to that point, because our calculator can't do the cotangent ratio though, it can do the what? Tangent ratio. You have to remember it's the reciprocal. Okay. So 1 over the tangent of 42, our calculator should be able to do. So that's what you got to do. 1 divided by the tangent of 42. Let's check my answer key. And the directions say round it to nearest what? 100. And that's where I'm getting that 1.11 from. Okay. Today we're going to do the same thing. I'm introducing you to another one for sine. We're going to do the same thing today. Okay. All right. Anything else anybody's got? This is your time to ask. Now, as we got on here, things to keep in mind, make sure you can obviously keep doing. Special rights are never going to leave you. Read the directions very carefully. Make sure you get things not mixed up. Tuesday next week will be our quiz over everything we're doing right now. Trig, the reciprocal functions. Cotangent, new one today. And I will keep intermixing the special rights. So make sure you read the directions carefully. That's what we're using our trig. And then on the previous side, right there, there's all of our trig work. That's what I'm looking for. And then down here, our practice within that reciprocal function. Making sure that you can do this. And hopefully, again, you realize, I guess I just realize I did not put those two answers out there, did I? I must have got sidetracked. So my answer on that one, sorry, I didn't realize that, did I? Come on, Dave. So I get the tangent ratio, and I guess I got sidetracked. I made the answer key. Let me finish this one off. So on letter B, hopefully again realize I try to put the final answer always in red. And if I got other work step I'd have to do to get to that point, I put that in a different color. So I always start off with the tangent ratio on this one, and on this one here it's angle F, I guess. So opposite over adjacent, 6 over 2 root 6. And then what's the cotangent ratio? That's F is what? 2 root 6 over 6. And then what can I do with that? 1/3, right? So the answer should have been what? Root 6 over 3 for the cotangent ratio. I need to update that too. So on that one, that's what I did. I always start with the tangent ratio. On that one there, opposite over adjacent. Okay, to start off with the tangent ratio, cotangent ratio, 32 over 40. One more time, that's going to be a good answer. That's the first answer I'm starting with. And then I always want you to see if you can reduce it. I did on the other one. Here, I can do the same thing. You can let your calculator do it. You can do it by yourself. I don't care. Just make sure you reduce it correctly. So the final answer is, what is that? 4/5 is what I want as that final answer. Okay? I need to make sure I did the keys. I did not. All right? All right. Anything else? 2C? Where's 2C at? Right? Yep, right there. All right. Tangent. And I did not write the opposite over adjacent, did I there? So, dumb mistake on my part. On 2C, with that, all right, as I do that X right there, I wrote adjacent over opposite. It's just a dumb mistake. So, as Eric's pointing out, opposite is the 8. Adjacent is the, the adjacent is the 5. So opposite over adjacent, opposite over adjacent. We're still doing the inverse tangent, arctangent. I just didn't have the right ratio, did I? So second tangent of what is it? Should have been not 5/8, but thank you. So that's going to change it up, I believe, not to 32 degrees, but yeah. So what I actually ended up doing here is I stood at the other angle, didn't I? I ended up doing the complement to it. Okay, so 32, but not that. It should have been 58. All right, thank you. We'll fix that one as well. Okay, make sure your name's on it. Throw it in the basket. In order to do the sine ratio, which we already know, which angle would you have to stand at in order for the sine ratio to work? So, standing at angle H, go find me now, the measure of angle H, using the sine ratio. Okay, using the sine ratio then. All right, correct. Because as we've been doing here, excuse me. All right, we've already known our trig ratios, our little mnemonic device that kind of helps us out there. Now, I don't have a mnemonic device for the reciprocal functions. You just got to know tangent, cotangent go with one another. But so, for the sine part of things today, you said go stand at angle H. What is it? 8 over 17. Again, on Tuesday, that's when I quiz you up on the first time through things. I'm looking for 1 point for the equation. Second point's going to be for the calculator ready, solving for the variable. So I'm looking for the inverse sine, also called arc sine. All right. And then how do we solve for the variable there? I'm sorry, how do we put that into the calculator, I should say? One, I always do. Oh, I'm already in degree mode. Nice. I did say for whatever reason. Second sine, right? Inverse sine of 8 over 17. Again, where do we typically round the angle measure? Nearest degree. That is our default, correct. So in this instance, it's going to be what? About 28 degrees, correct. That is, again, our defaults, unless the directions would say otherwise. Alrighty? So 28 degrees. Great. Let's piggyback off the sine ratio today. So the sine ratio we know is what? Opposite over hypotenuse, right? So with that today, as we've been doing the sine ratio, we've got a lot of practice already in with that. Let's talk to you about its lesser known cousin. That's what we call it in the cosecant ratio. So sine and cosecant, they go together. And we shorten the cosecant ratio down to CSC. Okay? Again, I don't have a stellar mnemonic device out there for you to remember the cosecant ratio. You can remember then cosecant as, I always just remember as the reciprocal, excuse me, the reciprocal sine. So therefore, what is the reciprocal of sine? Hypotenuse over the opposite, right? So I never remember it like that. It just sounds weird because I know sine is opposite over hypotenuse. But the way that I always think about cosecant is 1 over sine. Okay? 1 over sine. That's how I just always remember it. Because I know what sine is. Sine is what? Over h, right? And so cosecant is h over o. If you remember sine, cosecant's the flip of that. So however you want to put it in your head, I don't really care. You can remember it like that or 1 over sine. Okay? I like 1 over sine because we used that just a few minutes ago in the question Luke had. That's what we have to use in our calculator. So that's how I like it. But it's totally your call. All right, let's do some work with what today? Cosecant. That page doesn't have the work. I think next page does. Down at the bottom, I believe, has a couple triangles. Let's do the cosecant ratio then. Just like we did yesterday, the cotangent, but let's do the cosecant. I want you to right here underneath this triangle, I want you to go stand at angle A. I want you to write me the cosecant of angle A. Okay? Now, when I do the cosecant ratio, just like I did yesterday, I always go back to the original. What's the original of cosecant is sine. So in my head, I'm always writing the sine ratio first. Sine ratio is opposite over hypotenuse. So for me, that's what I always do. I know what 4/8 is, and I flip it. So what's 4/8 flipped? Reciprocal is 8/4. And then I deal with that ratio. Sometimes it's, as we know, whole numbers here. Sometimes it's radicals, whatever. I deal with what I got now. I never deal with it on the sine ratio. I deal with it through the reciprocal. Okay, what can we do with 8/4? It's just 2 then, right? But I always want you to go back first to the what? Well, I should say I always want you to. If you can remember it, cool. All right, let's go with another one here. I would like you to, again on this one, let's go do cosecant ratio again. But I'd like you to do the cosecant at angle B. Okay? Angle B. Cosecant of angle B. All right? So cosecant of angle B. B. We're still on that first triangle. So again, I always go stand at angle B, and I'm going to do the sine ratio first. What's the sine of B? 4/3 over 8, isn't it? So in my head, not even just in my head, as I'm making my keys, I'm writing that off to the side. Okay, and then I'm going to do the reciprocal. That's where I'm going to put that down. And before I do anything, I jot that down, and then I deal with it. I deal with it now. Now what do I mean by deal with that? Okay, what can I do with 8 over 4/3? I got 2 things I can do. I got to rationalize. What else can I do? I could reduce, right? 8/4. That's just the next one. 8/4. I'm gonna get rid of that 8/4. Reduce those numbers first. Save yourself a little bit of headaches with the signs of numbers. 8/4 becomes just what? 2 over. Yep, 2 over 1, 2 over √3, right? Now rationalize as Eva suggested. Okay. Do you have to do that first? No. But it just saves you some smaller numbers to deal with. Okay. Less chance for some issues to work with. Now I'm gonna have to rationalize for sure. Okay. And this is where some of you need to make sure you're doing that practice, because a few of you screwed up the rationalizing. You did correctly here, but the next step is where you messed up. 2√3 over perfect square of 9, right? And the square root of 9 is perfect, isn't it? and that's my rationalized form. Okay. Nothing super crazy. We've done ratios already for lots. Nothing crazy here. All right, let's do one more there. Let's take that 45 off to the side. What angle do you want to stand at? E or D? D. Cool. I don't care because they're going to be the same, isn't it? So let's go stand at angle D. Let's go do the cosecant ratio at angle D. So if I'm going to do the cosecant ratio of angle D, as I keep doing here, I like to do the sine first. Stand at angle D. Sine ratio. What's my opposite? What's my hypotenuse? 8 and 8 root 2. I always jot that down first. Go with something I know. And then I flip it. I flip it, and what do I got? 8 root 2 over. Do I even have to rationalize, actually? No, because the reciprocal took care of it, didn't it? Only thing I have to do is, cancel out the 8s, reduce the 8s, and gets me just, and I'm done. Okay, and I'm done. So, nothing really crazy. You've already done all the heavy work with knowing ratios. Yesterday we introduced you to the first reciprocal function. Today I'm just introducing you to the second one. Okay. Now let's do another thing on this page. Find yourself that hopefully got a little bitty white room right here, some blank space, maybe up above, like we did in that yesterday. It's a good SAT part. It's a good part for the next part of your adventures through Algebra 2 and Pre-Calc. I'd like you to evaluate for me the cosecant. Somebody give me a number. Go a little higher. 6. All right, that's much higher. We're going to go 6. Thank you. There's Uriah, 6 degrees. Go evaluate for me. Let's round it to the nearest 1,000. Okay, 6 cosecant of 6 degrees. Now, just like we talked yesterday with cotangent, you can look through that calculator. Your calculators do not have the cosecant button on there, does it? So how are we going to rewrite that so that we can use our calculator? 1 over sine. That's it. You did yesterday with cotangent, 1 over tangent. So today we're going to do 1 over sine of 6 degrees. And I said, excuse me, 1,000, please. 1,000's how many decimals? 3. Cool. So what's that mean then? 9.56 what? 7, right. 9.567. Okay. All right, now we're going to continue working here today, but unfortunately, our book, again, doesn't have stellar practice in the next piece we're going to do, okay? So here's what I'm going to do. Pass out the next piece to you. You're going to then tuck these into your page, because we're going to do this today, and then we're going to continue it here later on, this week. So let me pass it out to you. Or not. I was about to say, it's all relative to where you're at, and when you say, and you hear the word elevation, what comes to mind with the word elevation to you? Okay, keep that in mind, up, increasing. And what comes to mind with the word depression? Down. Sometimes people say math. I get it. Okay, I get that. All right, but up, down, that's really where you want to be at. All right. So with that, all right. Okay, let's go look at angle 1. Angle 1. Now, with these angles of elevation depression, first off, they're all built off of a horizontal line. Okay, so as we are standing where? At the top of this building. We all have this imaginary horizontal line. So we're all starting off like this. And off this horizontal line, angle 1 is being created how? Are you looking up or are you looking down? Looking up, correct? Where are we looking up at? We're looking up at the plane, right? So as you look up, how did you classify angle 1 then? Elevation. That's it. Because you've got this imaginary horizontal, everybody has this imaginary horizontal line here. And that angle is above
that horizontal line. And with that angle being above that horizontal line, looking up towards that plane, we classify that as an angle of elevation. Okay? Angle 2, where's angle 2 at? Okay, you're still back, reset yourself. You're standing at the top of the building, reset myself. What catches your eye now? The car. You look down. And as you look down, where is that angle being created plus is? Where's the angle being created at? It's below that horizontal, isn't it? And because it's below that horizontal looking down, what would you classify angle 2 as? Don't overthink it. Okay? It's an angle of depression. It's directly below, created by that horizontal, directly below that horizontal. It's an angle of depression. Okay. Driving along the car. Still got this, everybody has this imaginary horizontal line. Everybody does. So, driving along the car, what's the car do here? Ooh. Where's the car looking at? It's looking up to the building, isn't it? So everybody has this imaginary horizontal line. So think about the ground as the cars drive along the ground, or the car is just driving along and everybody has this, again, imaginary horizontal line coming out of you. All right? And the car looks up. So angle 3 is then considered to be a what? Right, because you're looking up towards that building, right? So angle 3 is considered to be a what? Elevation. All right, so think about maybe the ground as that. 4. All right, 4, I got my plane. I wish it. Okay, I got my plane. Or I'm probably a passenger on the plane, more likely. Okay, I look out my plane, and as I look at my plane, what's angle 4 classified as? This one's a depression because it's formed with a, I keep saying this word of imaginary horizontal line, right? So it's below that horizontal line. It's a what? Depression. Now I said there will be one neither. Why am I classifying 5 as a neither? I'm sorry? It's not off of a horizontal. 5 is below a line, is it? But is 5 being created with a horizontal line? No. So yes, it's below a horizontal, but is it adjacent to a horizontal? Is it sharing a side with the horizontal? No. 5 is the neither. Okay, 5 is a nothing. Okay, 5 is neither. Okay, so it's got to be off a horizontal. Everything has to be off a horizontal for elevation and depression. Now, off of these, the angles of elevation and depression. This elevation, depression 1 and 4, and 2 and 3, those are congruent to one another. 1 is congruent to 4. 2 is congruent to 3. So if I'm at the top of the building and I can see somebody up in the plane and somebody in the plane can see me at the top of the building, as we lock eyes, are we staring into each other's eyes? We're congruent to one another. It's not my wife that I'm looking into. Don't tell her that, though. Don't tell her, Chloe. All right? Boy, I may have a lot of trouble with my wife here. Okay? Or if I'm staring at the top of the building and I lock eyes with somebody in the car. All right? Good morning, Sam. All right? Sam. All right? And I look down at that car. Again, we lock eyes. That angle was at 2 and 3. Those are congruent to one another. Anybody can tell me why? Why those are congruent to one another? What's that? You're on the right track. Not quite the right angles, but you're on the right track there. He said linear pair, vertical angles. He's on the right area, but not quite. Can you help him out? These are horizontal lines.
They're
Parallels.
alternate interiors.
There we go. Deontay started us off on the right track. There are parallel lines going on. And then we have alternate interior angles are congruent in parallel lines. There you go. Okay? So, that's something that is going to be key for us as we work through the next few days here too with these word problems. An angle of elevation is congruent to its angle of depression. So let's do one. Draw me that picture. Now when we say wind turbine, just think about a windmill. Okay. If you drive up 55 north, maybe about an hour and a half away from here, there's a big old windmill farm on the left side, right side of the road. Yep. So just think about a windmill farm. Now, how you draw your picture, how artistic you are, totally matters. It does not. It does not. Okay. Because my artistic skills, as I've drawn here and there for you, I know they're awesome. I know they're stellar. So
I can't live on.
I'm for real. I'm for real. Yes, I know. You know I don't joke. Okay, very serious person. Okay, he looks like a flower. Fair enough. You're still looking better than mine there, Brianna. All right. There's my ground. Nobody in here is an art critic. Okay, except me. I'll be the art critic. We're here totally for real. Windmill is how many blades usually?
3.
5.
3.
5.
Mine has 6. Mine has 6.
Windmills have three blades there. Okay, got mine going with a little peace sign there. All right. So everything is built again. What type of triangle though? For all this to work, it's got to be a right triangle.
Okay, good.
Correct. So we got to assume, this windmill is built at a right angle. So this picture here, windmill at a right angle, looking down to the ground. You are someplace teeny tiny looking down at the ground here. Okay, and we're assuming this windmill is at a right angle. Throw in that information. If you can't visualize that triangle, and again, honestly, with your artistic skills, it all boils down to what? A right triangle. Okay? You got a gigantic sunflower. You got a gigantic peace symbol going. I don't really care. It boils down to a right triangle. So, where's those labels going? You stand 53 feet away from it. And your angle of elevation now. Where are you at in your angle of elevation to the hub of the turbine? So I've got two angles up here, top angle and bottom angle. Where's that going to go then? It's the bottom one, right? Where are you at? Where's the hub at? Everybody's got this imaginary horizontal line. You're at the ground, and where's the hub? It's up in the air. So where's that angle got to be? It's got to be down there at the bottom with the ground. 56.5 degrees. Put yourself in that picture. I know it's word problems. We know our past history of word problems in elementary school, middle school. Just try to visualize these. Where's the variable going to go? On the what? Vertical leg, I think I heard.
Yeah.
Okay, that's the geometry, the first part of the geometry with visualizing it, labeling it. Go to the second piece. Obviously. I like that. I need to laugh. All right. Sine, cosine, or tangent. Sure as hell not 36 or 45s, is it?
It's a tangent.
It's a tangent, right? Standing at the angle, we have the what? Opposite and the adjacent, right?
Yep.
Okay, tangent of 56.5 equals what over what? Opposite over adjacent, right? All right, cool. Now we got that. Solve for x. We've done all this stuff now. It should be old school at this point. X is going to be what? 53 times the tangent of 56.5. Let's go to our calculator. I don't know if it says word around. Does it say word around? Nope. Now in this instance here, once we plug it into our calculator, is a nearest tenth really going to make a difference?
Yeah.
It is? Probably not. So in this case, 80.1 I'd be fine with. On the quiz and test, I will be very specific. 80.1 or 80 feet, I don't care. So 80.1, 80 feet, I don't care. I'm just gonna go with 80.1 feet because that's what we've been doing for our side links. Okay. So, what's that, Yante? Nothing? Okay. All right, let's go to the next one. Let's do one more here before our bell rings. Angle of depression. If you're already not depressed enough, let's depress a little more. First hour math class. You're all elevated, right? No. That phone was not elevated. But I'm home. Shh, I'm here all day, guys. I'm not. Just 3. All right. So from there, a pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. All right, sketch that thing out. Yeah, can't wait to see you guys on this one. Let's draw some waves. Let's draw the ocean here.
My airplane is terrible. It's kind of choppy.
Is it a choppy ocean?
I haven't got to the ocean
Life rafts. Life rafts are what color?
yet. Red.
Oh, wow. We don't know our maritime laws, do we?
Yellow.
Red. Yellow.
It would be
Red,
yellow.
orange, yellow. Orange. I said
Should be a bright orange. Should be a bright orange. Maritime laws say it should be a bright orange.
Mr. Chris, you're not an artist.
when are we all in the ocean?
You're not.
You broke his heart.
Deontay, you just stabbed me here. Okay, here comes my.
Oh, mine's beautiful.
Keep drawing. Here comes my life raft. It's gonna look more like a dinghy, actually. Probably. I'm gonna go with the dinghy. I'm gonna shade that in so you don't see that. It's a life raft. Now-
look like a life raft.
Okay, it's supposed to be
You know
oh,
what?
it's like one of them
You
ones
look
that
like a life raft.
Okay.
Okay.
It's like an inflatable.
Can't wait till somebody goes that's absent today, like Julian, and goes listen to these video, watches this video later on, and she gets to listen to this commentary. All right,
You should be happy.
and then we'll put a little sail on it because all life rafts have a sail, right? Okay,
There's not a sail.
I'm aware of that.
They're on
Okay.
regular boats.
Yes, I'm aware.
You don't just blow up a little
Okay.
flag.
You gotta use the imagination.
Thank you, Zariah. Zariah's on my side. Let's draw your airplanes, guys.
I already did.
Yeah, let's see what your airplanes look like.
Let's see what
Oh
yours looks
gosh,
like.
no.
It's gotta be the one coming up
Oh,
above.
gosh.
Great.
I'm worried about this one.
Yeah, I am too. My airplanes are not at all. They look like a gigantic pill capsule.
Oh.
I was actually really good at drawing
Okay.
airplanes.
Well,
They don't belong.
Good.
Where in school?
I should probably go higher. I probably should go higher. Or blimp, I should say. Okay,
That's a balloon.
Oh.
give me
Oh,
a
that's
second.
cute.
Oh my
Okay.
god.
Mine's better.
Oh, I'm sure it's better. I'm sure it's
I
better.
copied the one from
You should ask Mrs. Dresch Chloe tomorrow to draw you a much better picture. You get the wrong Dresch for this one. All right, I thank you, Chloe. And it's to scale too, isn't it? Okay, so from definitely thank you.
I like that.
Soraya and Brianna get the ace with you guys. The rest of you fail. All right, you're over there critiquing me like anything.
I'm about to draw the best plane. Hang on.
James,
All right.
be careless.
Shut up, Eva.
Let's go. We got this life raft. Boom, we spotted it.
But we did.
And everything has this imaginary horizontal line, doesn't it?
Yeah.
So from the airplane's perspective, as it's flying up there at the altitude of 3 kilometers, there's still this imaginary horizontal line. So this angle of depression that's created, it's always below a horizontal. 26, it says. Now, what is altitude for an airplane? It is the vertical distance straight down to the ground, to the ocean surface level, whatever the case is. Boom, straight down. It is perpendicular. Okay, in which case is what, 3 kilometers. Oops. And you should start to see then that right triangle being created. Okay. Now, I always like to draw that right triangle then right here off the surface level. Okay. And with that, all right, if you're on the life raft, you also spot that plane from the life raft's point of view, that's the angle of elevation. That's also 26 kilometers. Or not 26 kilometers, 26 degrees. What is the airplane's horizontal distance from the raft? Where is that variable going? Where is the variable going? On the bottom, right? The horizontal distance from the raft.
Yeah.
We're going to talk more about airplanes and how they differentiate between horizontal ground distance and line of sight distance, because there are two differences there. Boom. There's our beautiful triangle. We're done. Standing at the 26, that is my opposite and adjacent. Okay? Now, from there, I know time is ticking out. Opposite over adjacent. I'm going to go grab the assignment here. 3 divided by